Welcome guys to AQA Certificate Further Mathematics GCSE. Today we're on Chapter 8.1, Introduction to Calculus and Differentiation. This chapter is a grade A star, so yeah, that will be a bit more difficult, but it's going to be fine. I used to name my chapter according to the specification, but in this case, because chapter 8.1 according to the specification is gradient, and we've gone through that from the past and from GCSE, so there's no point on copying that. So I'm going to introduce you to calculus in the form of differentiation, and so yeah, let's begin. So, this video is going to be a plain old explanation video without any type of tips or any type of questions, so you just have to know facts, which pretty much is explaining why differentiation works. So, if you know everything about the basic equation for differentiation, you can skip this whole episode out and it's not going to do any harm. So yeah, let's start explaining gradients and why is that related to differentiation. So sometime in your life you'll have encountered this particular equation line which is basically y equals x squared, and this is from an online graph maker. So yeah, it's not particularly good and I can't really do much about it, but that will have to do. So if I want to find the gradient at 0.24, then what will you do? Well, classically you would have to use a line or starting from this and draw a tangent. So it's going to be difficult on the computer, is it? Try to extend that as long as possible, and that is definitely not a great nope, it's proving to be a lot more difficult, but I guess I will do something like this. Yeah, that will have to do. I know this is not a line, right? Doesn't matter, we're going to use the first line. So how do we calculate the gradient? Gradient is basically just difference of y divided by difference of x, or increase of y and over increase of x. So at 2,4, which is this particular point, yeah, let that be. I know that let's say because it crossed 1, so it increased in y 4 and increase in x by 1, so the gradient naturally is 4. Well, that is one way to find a gradient, right? And this is, I tell you, not particularly accurate, but it happens to be actually true. At that point, the gradient is indeed 4. This is by fluke, by the way. So yeah, let's go to some more accurate estimation of the gradient. So same graph, same gradient, same equation, but different scale. Obviously, I increased the scale so that it's a bit easier. And what you can do is a bit more accurate, because this is down to each 0.6 increment. So, and this is a 0.4 increment. Nope, 6. My math is terrible. So both of them are 0.6 increment, but the parabola is still a parabola. So again, we start from the good old basic 2, 4, which is it's not proving to be easy to find, is it? Somewhere along there. I'm not going to be like particularly fussy about that. So that is kind of our points, but now we need to find the gradient. How though? So actually this is not a good graph. I have to admit, because the things I've prepared are out of the graph. So I guess I'll have to, well, you'll have to trust me on this one. You can't really draw things out of things. Well, out of nothing rather. It's like somewhere up there that I can reach with my cursor. So yeah, let's start on point 2, 4 again, which is here. Roughly, not accurate. And I want you to do me a favor. Draw a graph using a graph paper. Draw a parabola. I think you should be able to plot a parabola by now. If you can't, then it's probably a big problem for you in the exam. Definitely not my problem. So yeah, I want you to plot these reference points. And yeah, these are the x and y values. Down here, I don't really worry about that too much, because it's too small to be negligible with your finger and your pencil, whatever. So yeah, so that is the first thing I want you to do. And in the next page, I'm going to show you why these will lead you to the gradient of that point. Well, I know you've now got 5 different points. Well, 6 different points, including the starting point, which is 2, 4. And so now, what I want you to do on your graph, to connect each of those 5 points to the starting point, which will create a sort of a just doing that impression kind of, oh, this is terrible, never mind. So let's say this is what your point is, and you should have one here which is 3, 9, then you have one about halfway, then another one at 1.1, then it's just a matter of tinier and tinier. So I want you to connect them with a straight line, of course, not this one. Yeah, something like that. Just remember, straight line. I can't draw straight lines on computer. I can't use a mouse. So yeah, what you should be able to do is to find the gradient of those lines, which conveniently I have a better way to do this, because we know the x and y coordinates of those points. You don't really need to draw lines. You can do the change in y, which is the point's y coordinate minus the old starting y coordinate, which is 4, and same with x coordinate. You should get m, which is the gradient. So I'm not going to let you do these because it's a bit too tedious and a waste of time. So yeah, these are the answers. The first one will be 5, gradient of 5. Second is 4.5. Third one is 4.1. Then obviously you can read. I'm not gonna say those decimal points like a fool. But now you can see that there is a trend indeed to this sequence. As the change decreases to, well, near 0, the result of the gradient converge to 4. What does that mean is that if the change is too small to be to take into account, then it should, in theory, be no change. So it's on that particular point 4,2, the gradient will be the converged value, which is 4. And on that graph that I beautifully fluked, the answer is 4. So actually, those two prove each other. The gradient of that 2, 4 is actually 4. So this is another way of proving, well, how to find gradients. But this we can develop one step further. Remember, this graph or this equation only works with one starting point. What if you want to find a certain gradient on a curve on each single point? So by the time you're watching this scene, you should be saying, why am I watching a full rambling about stuff that's not related to gradient? And well, it's related to gradient, but nothing with differentiation. What I want to prove to you on the last scene is crucial to understand how differentiation works, because as the change of y or the change of x reaches 0, the result will become, well, 4 in this parabola on that single point. But it can be explained so that it works with every single point on the graph. But I'm not going to explain that, because that will take so long and it's going to confuse all you guys' brain. And I know you guys just want an A or an A star, so I don't really need to talk about S grade stuff that you don't really need to use in any kind of exam. So if you trust me, or if you trust the syllabus, or if you trust the theory, then keep watching. If you don't, then seriously, you can't do differentiation because you don't trust it. So this is the equation that we're using. So what is a gradient? Is obviously the change of y over the change of x, or we can put them into its original name. This is delta, or well, delta is a triangle. It's like this, but we're using D instead of a triangle as delta. Delta in science means change, and it is used in math to be to represent the change of those coordinates. So what I need to tell you is, because we have proved that the change, well, we didn't prove, but we know that the change of y over the change of x is the gradient. So the fraction dy over dx is also known as the gradient function. And this is exactly where differentiation starts. It all starts with dy over dx. So what does that achieve? Well, we know that there is definitely an equation to differentiation, and differentiation is basically to turn y into a dy over dx. But how? So I'll say, well, if you want to turn y into dy over dx, you need to differentiate. But we still don't know what is differentiation. So I'll show you right here, right now. Differentiation is to find the gradient using the known x value, and all the x value, when changed into differentiation, the gradient function will undergo a certain change. And because of the beauty of we're living in a advanced age, we don't need to do this proof ourselves. It's given by this equation. X to the power n will go into nx, which basically you pulled this number down to the front, and the n will reduce by 1. So in this case, y equals x squared will go into dy over dx equals 2x, because the 2 became 1 up there, so there's a hidden power 1, which is itself x. So we don't need to write that down. We know the gradient function is 2x, but how do we prove that? Remember we said that at point 2, 4, which is 2 x coordinate and 4 y coordinate, the gradient is 4. If you put the x value in, guess what? You get 4. How awesome is this? You don't need to draw any stupid graph, or don't need to do anything, any stupid calculation with your calculator, which takes ages. You can just use differentiation to get the gradient. So yeah, that is good. And last thing I need to add is that the dy dx has a longer name. I can't say it's better, but it's definitely longer than dy over dx, but it gives a bit more detail. This name is the change of y with respect to x. So when you differentiate something, you're looking at the gradient of that point, the point on the x-axis that is affecting the results. So yeah, that's basically it for these. So that's it for introduction to differentiation, really. You only need to know or remember this particular formula. It's just important to remember, and I don't think there will be equations for differentiation on the first page of the further math exam. So this is something you have to just remember. And yeah, just basically move that value to the front and reduce it by 1. If it's 3, then it's going x to the power 3, then it's going to be 3x squared. If it's x to the power of 1, which is, well, x, then it's going to be 1 times x to the power 0, which is 1. So that's quite simple, really. That's differentiation, and the gradient function is known as the change of y respect to x, or in respect to x, or with whatever. So yeah, so that's all from me. I hope you have a bit of clue about differentiation, and I will see you next time with some practical questions and a bit more understanding to differentiation. So that's it. Thank you guys for watching. If you learned something, remember to leave me a like and comment if I did anything wrong or not too clear about. And I will see you next time.